Hey, welcome back to my channel. Welcome back to the $2 million spec home build project. This is a project where I'm building my fourth home ever. It's a 6,000 square foot home. I'm also building a pool and spa in the backyard on 1.5 acres to try to sell for over $2 million to profit myself near $750,000, all in the course of a 8-month time span. Today is day number 65 of the project since I broke ground, and we're completing the insulation trade. Insulation is incredibly important and has to be done exactly correct the very first time, because then of course it all gets covered with drywall and there ain't no going back. I'm doing a completely encapsulated building envelope, more on that later in the video, but I'm accomplishing that by using the controversial building material spray foam in combination with the popular building material Rockwool. And given that I have living in a home that I built myself whenever I built what I called my dream home at the time, I learned that I probably lacked some attention to detail on the efficiency and insulation trades of my previous home builds. Given that I've went through that and learned that, I'm doing a much better job just being a better builder on this project by using some very upgraded building practices and building material to make sure that this home is incredibly efficient, and I just do a better job as a home builder. So in this video, I'm going to give a breakdown of all the methods and materials I'm using to make this as an incredibly efficient home, as well as, if you stay to the end, I'll give you a breakdown of all of the cost of what it costs to insulate this 6,250 square foot mansion. Let's go. I just went inside to turn the installer's music off, and I just got doused in spray foam, so that's probably not good. And it's in my hair. But I'm in Houston, Texas, and there's probably 3 real main options that you can go with insulation. Now, of course, there are more than what I'm gonna say, but here's the main common 3. You can either go with bats in the walls and then bats in the ceiling joist, which gives you a vented attic space. That means the attic space is gonna be, in our Houston hot summers, 150 degrees. And that, of course, is the most economical when it comes to cost, the cheapest by far. Next up is option 2, which is gonna be a combination of bats in the walls and then a spray foam roof deck. That gives you the encapsulated envelope. More on that later in the video, like I said. Many benefits to that, but there's a step up in cost, and there's many benefits that come with option 2. Option 3, probably the most superior depending on what you're looking for, and that is spray foaming the walls and spray foaming the roof deck. Although spray foaming everything is by far the most expensive option, therefore I've elected to go with option 2. Rockwool in the walls, spray foam in the roof, and it's going to allow me to accomplish that total encapsulated building envelope. Let's go inside, and I'm going to explain 3 critical elements that I have to make sure I take care of as a home builder to make sure this performs extremely efficiently. To build a house that is waterproof, moisture-free, mold-free, and just efficient overall, there's 3 main barriers that I have to focus on this project. That's a water barrier, an air barrier, and a thermal barrier. So I'm going to show exactly how I'm doing the barriers on this project. There's actually a 4th barrier called vapor barrier, but I'm going to leave that out of this discussion because I believe in what I've learned is if you take care of these 3 barriers, then a vapor barrier isn't really a problem. And yes, I know there's hundreds, if not thousands, of ways that you can build houses across America. This is just how I'm doing my house. So here I have a diagram of a house. And the first and foremost thing you'll notice is that all the barriers, the blue barrier, which is waterproof, air barrier, which is red, and thermal barrier, which is green, they're continuous, 360 degrees around the house, from the bottom of the floor all the way up the walls to the top of the roof and back down. Let's start with my water barrier. What's a water barrier? What's the purpose of it? It's, the purpose is to keep water out of the house, and it has to be continuous start to finish. If there's a break in the water barrier, would that be a very efficient water barrier? I don't think so. Obviously, water would get into the home. So the purpose of this is to keep water out of the home. You can see the arrows. It's going to fall on the roof and then go all the way down to the walls. And here it is my Tyvek and tape on my walls. And then it is, of course, my roof system, which is a shingle roof system. My air barrier is the red lines, which on this home is located outside of my exterior walls. And this is my Tyvek and tape system as well. It is my air barrier that's going to go up and stop at the top plate of my framing, at which point the air barrier transitions into the building envelope under the roof deck, where I'm spraying 6 inches of open cell spray foam on the underside of my roof deck. And you need 4 inches of open cell spray foam for it to become an air barrier. Lastly is thermal barrier. I have arrows drawing in here, and the purpose of a thermal barrier is to keep either your hot air in your home inside and keep it from escaping out, or to keep all your cold air in. Think of it like a thermos. Whenever you pour a hot coffee in, keeps the coffee hot. Pour in some ice water, keeps the cold water cold. Same purpose for a home. Thermal barrier here is my Rockwool bats, where I'm doing R23 Rockwool bats for all of my walls. And then on the underside of my roof deck is my open cell spray foam, which is also going to be like R21. So those are the 3 barriers that I'm focusing on doing a great job on this project to make sure that this project is just very high performance, it's waterproof, moisture free, mold free in the future, and overall a very efficient home. Over the course of the past 2 to 3 weeks, I've been doing all of the rough ends on the home for the plumbing, the electrical, the HVAC, and also the low voltage, which is a trade that is, I guess, getting very popular now, and you must incorporate, especially whenever you get to this price point of a home, for things like Wi-Fi, camera systems, surround sound, speakers. Let me know if y'all want a video on that. I can make one in the future. But over the past 2 to 3 weeks, we've got all the rough ends finished, and now everything is prepped and ready to go for insulation. And like I mentioned, on this build, we're doing 6 inches of open cell spray foam on the roof deck. We're doing R23 Rockwool comfort bat for all of the exterior walls. We're doing R38 for a cold floor. And also something I'm super excited about is I'm literally soundproofing this entire home. Every single bedroom, utility room, living room, media room, flex room is going to be sectioned off with soundproofing, a soundproofing system to keep each section individually separated and soundproof from the entire rest of the home. Before we get into the application, I want to go check on one other detail. One detail that I'm paying extremely close attention to on this project is penetrations. This is a detail that I paid absolutely zero attention to on the past, and it has affected the overall performance of my previous builds. But on this project, I am paying extremely close attention to it, not only from a waterproofing and air sealing perspective, but a design perspective. I have a roof that's about 80 squares large, which is a fairly large roof. On similar homes of this size, you typically see 15 to 20 penetrations going through a roof of that size. I was able to limit it down to 6. We don't have any plumbing vents going through the roof, any bath fan vents going through the roof, any dryer vents going through the roof. Instead, I only have 6 HVAC vents, and those are coming from the furnace. The HVAC contractor said probably wouldn't be safe to run these at that length to get them to vent elsewhere, so we need to put them through the roof. I have 3 furnaces in the attic, and 2 vents per furnace gives me a total of 6 roof penetrations. So I'm happy about that. And when it comes to the walls, I have tried to limit the penetrations as well for both efficiency and design perspectives. I'm someone who likes to, be proud of the design and try to do the design part of the build correctly. And I'm someone that doesn't just like GFCI electrical outlets stuck on the wall every 6 feet or whatever the case may be. I think they're kind of ugly, and for those reasons, I really try to limit the penetrations on this project from a design perspective, but also from an efficiency perspective. Just think about every penetration that comes through the roof or wall is somewhere that water can get in or out, hot or cold air can get in or out, and air can go through. So there's just something that's best to overall limit for efficiency purposes, but whenever they are needed, to make sure that you're building the home with the right practices. Well, here on this project, we are doing a great job waterproofing it on the exterior, and then on the inside of the wall, we're using a closed cell spray foam to seal up all of the air gaps to make sure there's no air that can get through. Here's the exterior where you can see we use a quick flash product over the top of each penetration, and this provides a gasket, provides a seal around the actual line or conduit or pipe coming through the wall. That is going to waterproof it in combination with a flashing tape that is installed from bottom to top. So that's a detail I'm paying close attention to increase the efficiency and the waterproofing on this home. Let's go check out one more detail on this project, and then we'll get into spray foam in the home. According to the Building Science Corporation, there are 4 main components that contribute to all of the air leakage in a home. That is the ceiling or roof at 30%, all of the walls at 25%, windows and door frames at 15%, and then all of the penetrations that we just talked about at 30%. So how we're handling the air leakage around the windows and door frames is we're using closed cell spray foam in a can, and we're spraying it where the window frame and door frames meet the studs and the window opening to eliminate all of that gap. The crew has all of the windows completely sealed. They're getting the windows covered, and the crew has already started spray foaming one section of the house. So let's get this roof deck spray foamed. So what is open cell spray foam insulation? Spray foam insulation is a chemical-based product that's sprayed directly into walls, ceilings, and floors. It starts as a liquid and quickly expands into a rigid foam, filling gaps, cracks, and irregular spaces. Once it hardens, it creates both an air seal and a thermal barrier, making it one of the most effective insulators when installed correctly. There are two main types: open cell spray foam, which is lighter, more flexible, and slightly lower R value per inch, but great for sound absorption. And then there's closed cell spray foam, which is denser with a higher R value per inch, better moisture resistance, and even adds structural strength to walls, but probably more than double the cost of open cell spray foam. Spray foam's biggest advantage is its ability to seal air leaks. It prevents drafts, stops moisture intrusion, and helps lower your energy bills by keeping air-conditioned air inside. It's also useful in tight or irregular spaces where traditional insulation would not efficiently fit properly. But it's not perfect. It can be expensive, tricky to install, and once it's in, it's permanent. If you ever need to open up a wall, you'll be cutting through a solid block of spray foam insulation. Also, it must be applied perfectly and correctly with proper ventilation, as chemicals can cause off-gassing during the installation. There are several ways that I utilize and applied open cell spray foam in this project. The primary application was on the underside of the roof deck, where I sprayed in 6 inches of open cell spray foam because I had 2x6 roof rafters, and that gave me a R21 insulation value at the underside of the roof deck. I contemplated upgrading to a R30 open cell spray foam at the roof line, but that is above the standard, and honestly it would have cost me an additional $5,000 to $6,000, and considering that I'm already $200,000 over my anticipated preliminary budget since I began this project, I don't think I can afford to make those certain kinds of upgrades. But R21 is sufficient and honestly better than the traditional just blown in fiberglass insulation at the ceiling joist. So yes, I applied open cell spray foam at the underside of the roof deck, giving me an R21 and that complete air seal. There's a couple other ways that I utilized and applied the spray foam, and that is at the band joist right here. This is actually a glue lamb, but I have band joists like this, very similar, going around the entire house, where I applied the open cell spray foam, because those areas had a bunch of air gaps and would have been very challenging to get in a bat of insulation in those areas. So pretty much any area that was hard to get to, such as tight corners, band joists, those are where I also used the open cell spray foam. Another place is there are some stud bays on this project, where this is a stud bay and there were pipes and wires and ductwork, whatever the case may be, running through it. I went ahead and did open cell spray foam in those stud bays as well, because it would have just been inefficient and challenging and not the right decision to try to install bats in those areas. And then another application is there was one hot wall on this project where my living room meets my back porch. I'm not going to get too much into what a hot wall is, but I pretty much just had it all blocked off, ready for insulation. And then I decided to go ahead and spray 1 inch of open cell spray foam on that back hot wall to completely air seal all of the holes and gaps in the blocking, and then go ahead and install the Rockwool bats over the top of it. And last, there's one main benefit other benefit whenever you apply spray foam on the underside of the roof deck, and that is it provides a continuous encapsulated building envelope. Instead of the furnace and the ductwork being inside of the attic that's 150 degrees here in the Houston hot summers, it's now going to be in a environment where it's probably 75 degrees in the attic. Therefore, it's going to last longer, not have to work as hard to keep the home efficient and at the right temperature, and then yeah, it's just going to last longer and perform better. Now let's go check out the Rockwool products that I decided to install in this project. So this is one of Rockwool's 5.5 inch thick R23 comfort bats that go in exterior stud bays. And this is my first time working with the material, and my very first impression is I'm just super impressed by how quality of a product this is. It's rigid. If you look at it, it stands up on its own. If you did that with any kind of fiberglass bat, it would simply fall on the ground. This stuff is dense and thick and strong, and in comparison to the fiberglass insulation, it is night and day. Just putting your hands on it, the quality, you can tell. This is a exterior wall, and all of my exterior walls are framed with 2x6s. That means I had 5.5 inches of stud bay that I could fill with insulation. Code in this area is only 3.5 inches or R13, and I decided to go with a R23 insulation in the exterior walls. That's almost double what code requires in this area, but I'm just trying to build a better house for the future homeowner, and this is a huge upgrade that's going to contribute to that. Not only is it an upgrade for our value, but there's so many other benefits to using a Rockwool product, such as the fire protection, the water resistance, bug deterrence, and many other benefits. Make sure to hit the subscribe button, because in the next video, I'm going to be doing some product testing, comparing this to other insulation products on the market with some small houses that I had my framer build for that testing. So now let's go outside and check out a building detail pertaining to the framing and how I built this house that contributed to a perfectly installed insulation trade where the exterior walls meet that spray foam roof deck. Let's go. So right now we're in the front of this project, and I actually designed this entire home, the exterior, the interior, and also the pool in the backyard that we're currently shooting the gun night on. So make sure to hit the subscribe button so you don't miss out on that movie where I build a pool from start to finish. But right now we're in the front of the home, and I want to talk about a detail that I included in the design that was a little bit challenging to build, but has paid off pertaining to the insulation trade. And that is what I'm going to refer to as flush framing. That is where the wall goes up and then transitions directly into the roof without any kind of overhang. Right now you see a small overhang of 5.5 inches up top at the gable corner, and then down at the bottom there's a brick ledge that's 5.5 inches. And that's because we're getting ready to install the brick. I just had all that brick delivered, and we're going to install the brick on the brick ledge, and it's going to stick out 5.5 inches from the exterior sheathing, actually a little less. But regardless, it's going to go up the wall, and it's going to tuck right behind that fascia board. Therefore, I'm not going to have any kind of roof overhangs where typically you have overhangs that are 12 inches, 16 inches, 24 inches or larger. Right here, the brick's going to go up, tuck right behind the fascia, and there's not going to be any overhang whatsoever. That's something that I saw was trending in the design transitional style home space. Therefore, I included it in the design of this project. I had to figure out what materials and what processes to go through to build it, so I got all that detail laid out on the building plans. Me and my framer and all the other trades up to this point have executed it perfectly, and now I knew it would have a little bit of benefits to the insulation trade. So therefore, the exterior sheathing goes up, transitions right into the roof. Pertaining to insulation, we are able to spray insulation on the roof deck all the way down to the top plate without having a big cavity to really block off if there was a large overhang. Typically, if there's a large overhang, there's a cavity right there that has to be really blocked off and paid attention to. Here, since it's just a 5.5 inch cavity of overhang, we simply put some blocking on the top, on the bottom of that overhang soffit area, sprayed spray foam all the way down the roof deck to the top of the top plate. It filled that very small cavity, and then right below the top plates is, of course, where we started the Rockwool bats. And that transition is extremely important to make sure everything just transitions smoothly and just perfectly overall for as good insulation as possible. By the way, I think there's 2 pros and 1 con when it comes to flush framing a house like this. I think the 2 pros are that first, it looks great and stands out from all the rest of the houses that typically have 12 or 16 or 24 inch overhangs. And the second pro is that transition when it comes to insulation installation. But there's a con And in my opinion, that con is that there is no umbrella hanging off the house. There's no overhang that provides protection to that exterior wall and those windows. Therefore, we have to provide extremely attention to detail on the waterproofing, on the Tyvek system, the waterproofing, on the window installation, because there's gonna be so much water that comes off the roof, and when the rain hits, it's gonna blow onto that exterior wall, onto the windows. In comparison to if I had large overhangs, all that water would simply get shedded off the roof and straight down to the ground. So those are the 2 pros and the 1 con that I've faced so far. But now let's go check it out inside. So here's how the flush framing correlates to the inside on the insulation installation. And that is that I have a continuous thermal barrier all the way from the bottom plate of the first floor through the top plate of the second floor, where it then transitions directly into the open cell spray foam on the underside of the roof deck, goes all the way up to the peak of the roof, and then back down the other side of the house. And yes, this is achievable with roof overhangs, but this flush frame detail just made it super seamless and stress-free for me as a builder, because I didn't have to do any kind of special framing or any kind of blocking details. Instead, we just did the flush framing, sprayed the spray foam in right above that top plate. It filled that very small cavity, and it created this perfect continuous thermal barrier. And that's how the flush framing was beneficial when it comes to the insulation installation. Now I'm in the 3-car garage on this project, where I made another upgrade, and that is insulating all of the exterior walls, making this a completely insulated area. This is a 3-car garage, about 1,000 square feet. I thought about even air conditioning this space, but I don't believe it would be worth it for me as a builder, because I wouldn't see a return on that investment, because it would cost me probably $5,000 to $10,000 to insulate or air condition this space. And as I already mentioned in this video, I'm $200,000 over budget, so I could not afford to do that. But I did choose to insulate all of the exterior walls. So this is a cold floor that separates the garage from the flex space. Given that above me is an air conditioned space, I had no choice. I have to insulate the ceiling joist right here, so that that is a thermal barrier separating the living space from the non-air conditioned space. So I had to insulate that, no choice. I also had to insulate all of the interior walls here that separate the garage from the house, the garage from the utility room, the garage from the mudroom, the garage from the living room. So those 2 areas had to get insulation no matter what. The upgrade was made where I decided to insulate all of the exterior walls, and also I'm going to be putting in some insulated garage doors. That's just going to regulate the temperature during the really hot days or really cold days here, as well as it's going to make it super easy for the future homeowner to move in here, throw in a mini split on an exterior wall or something like that, and really control the temperatures of this garage down to 70 degrees year round if that's what they wanted to do. So I'm using Rockwool's R38 insulation bats in all of the ceiling joists. And then of course, I'm using R23, Rockwool R23 insulation for all of the exterior stud cavities, and then open cell spray foam on all of the band joists here in the garage. Insulating the house the way that I did on this project really makes me understand how much that I have grown as a home builder. Just a couple years ago, when I built my first couple houses, I paid zero attention to anything related to efficiency, insulation, air sealing, waterproofing. I was just buying the material, scheduling the labor, and saying, hopefully this all works out, because it was my first one and I didn't know. Now, I did move on and do a little bit better job on my dream home build that I built last year. And obviously I've had the experience of living in for the past year, year and a half, and it has really opened my eyes to how much better of a job I should be doing as a builder. I have grown from then, and I've applied that growth and experience and knowledge to this project. And I'm not gonna say I executed it 100% perfectly, but I would say compared to my other projects, I did those very subpar, and I did this one a very good job on it. So I'm proud that I'm growing as a builder, and it really shows the way I insulated the home on this project. Taking it a step further, I also installed a soundproof system on this home that separates every interior space, all the bedrooms, the bathrooms, the media room, the flex room. Everything is completely separated and soundproof. I'll be making a video on that in the future, as well as let me know if you think I should do a blower door test on this project. Most places in America, it is required by code, city ordinances, city, county, building departments. You have to get a blower door test to make sure that your home is efficient enough, essentially, to be able to then obtain your certificate of occupancy to say that it is safe for, I guess, someone to move in there and live the home. If you don't pass the blower door test scores, then your home doesn't meet code, no one can move in. Here in my specific area, it is not required by code or the county building department. I didn't plan on doing it, but I'm curious. Would y'all like to see a blower door test on this project? I'm kind of curious myself. what I would score on that blower door test to see if I'm really doing a good job or how much I've really improved over the past. So anyways, let me know if y'all want to see that. Now for a cost breakdown, the spray foam installation cost $10,300. The Rockwool material cost somewhere around $20,000. And then the installer installed all of that Rockwool insulation for me for $5,660 labor only cost. Now the only thing there, that $20,000 Rockwool material cost, I partnered with Rockwool on this project and they gave me that Rockwool product all completely for free. So I want to say huge shout out to Rockwool. You know, I don't take brand partnerships lightly. I'm sure that at this point, if you're a viewer of the channel for a while, you see that, because I don't do a bunch of brand partnerships. I could do a brand partnership in every single video, and this is the very first partnership that I've actually taken up on. A lot of it comes to the brand ultimately, or the company ultimately has to pay me enough money and make it worth it for me. As well as it has to be a good product, and Rockwool did that. They made it worth it for me. And also, I truly believe that they have a awesome top of the market products, and I highly recommend the open cell spray foam Rockwool combination insulation system like I did on this project. I think the only thing that may be better than that is a closed cell spray foam system on your entire home, but that is like probably three or more times the cost of the insulation methods that I did on this project. So again, huge shout out to Rockwool. I know that y'all have an incredible product. Hopefully we can continue this sort of partnership and I'll install it in all of my future homes, because the installation went incredible. It's a very dense product. It has all of these different qualities that are huge benefits in comparison to other products on the market. And I'll be making another video on the Rockwool products in the future, showing how they're waterproof, how they're fireproof, mold proof, bug proof, and all the other qualities in comparison to other products on the market. So huge shout out to Rockwool. And hopefully y'all appreciate I don't just bombard you guys with ads for an extra $1,000, $2,000 per video, because it's just not worth it for me, and I want the viewing experience to be better than that. So hopefully y'all enjoyed this video. I do not know what video is next because there's so much going on here at the project. You can see we already got windows in and maybe about 2 months left here on the build. So thanks for watching. I'll see you on the next one.